Good day, ladies and gentlemen. It's our biggest honor you are here. My name is Chen Wang, General Manager of Rigol Europe. Welcome to our press meeting. Thank you.
My name is Boris Adlung. I'm also quite happy to see you here during our press conference, and today we want to introduce our newest technologies. First of all, we want to give you a brief introduction of our company. Here you can see the three young students from 1998 who started this company. You can also see the English names of these three gentlemen. The characters of their English names is the form of our company name, Rigol. These three gentlemen are all still the owner of the company. This year, on 8th of April, we went to the Shanghai Stock Exchange market, to the STAR market, which was quite important, and this brings us the success to generate, for example, brand new R&D center in Beijing, Shanghai and Xianyang to improve more our R&D capabilities and bring more technologies for our customers. And the result are our patent wall. Here's the update from end of last year. In the meanwhile, the numbers are higher. And Rigol has also the most patents for oscilloscopes in China. One core technology for Rigol Technologies is the development and the design of our own ASIC chipsets for our oscilloscopes and RF probes. For example, the first chipset, as you maybe know, is the Phoenix chipset, which was launched in 2017. And here you can see all the products what we already launched with these chipsets. For example, the UltraVision 2 platforms, which contains our 2 GHz oscilloscope MSO8000, launched in 2019, our DS8000R, 2 GHz rack mount oscilloscopes from 2021, the first oscilloscope with this chipset, the DS-MSO7000 from 2018, and of course our mid-range scope, what you maybe know is our MSO5000, also from end of 2018. Additionally, we launched also a new RF probe up to 7 GHz, what you can see here at the top. Beginning of this year, we launched also with the UltraVision 3 platform our DS-70000, which has 20 gigasamples and up to 5 GHz bandwidth. In this slide, you can see our mission and our vision. Our mission is, for example, to provide our customers the possibility to design the newest and best technologies which will help all of us in the future and goes to the border of the possibilities and maybe more. We want to give and bring technology and test devices for industry area, for aerospace area, but of course also research centers and educational area. We have test devices for the semiconductor area, for the communication, for new energy, but of course also for the intelligent industrial manufacturing. The next part of the presentation is to demonstrate to you the already launched products in 2022. Beginning of this year, we extended our already known DP800 series with 2 new products, which have the possibility to bring much more current. The first one is the DP831A, which has the capabilities with 1 channel but 2 ranges. The next one focused also to have more current, so therefore we developed the DP822A. It's a 2-channel power supply with 180 watt total power. Several weeks ago, we launched our new DC power supplies on the market. We have the DP900 series, and we have our Mercedes, I would say, the DP2031. For this one, I want to go a little bit more deeper inside, because this one is a brand new power supply where we concentrate to have more speed, very good power level, and much more functionalities than before. For example, when you want to work with it, we have a modern touchscreen, or you can use it with web control as an example. The channels itself are completely isolated. In case you need the double voltage or the double current, you can combine internally channel 1 and channel 2 together. We have different voltage and currents of each channel. For example, channel 1, channel 2, they have 32 volts and 3 amperes. Channel 3 has 6 volts and 5 amperes. And optionally, you can also adjust it to 10 ampere for higher current applications. But not only higher current is important, also the low current is quite important. Specific when you work with IoT boards, they are on sleeping mode. Sometimes you're working with very, very small currents. Therefore, we developed here a low current mode where you have a high resolution below to 1 microampere. We generated also a speedful analysis tool inside. That means we can display curves with a sample rate up to 7.5 kilosamples per second for current. We also implemented here inside an ARP generator where you can generate ARP signals for voltage and current up to what you want to know. And the step size is 1 milliseconds or bigger. We have also different interfaces in the test device like LAN, USB 3.0, RS232 and optional GPRB. Here you can see the overview of the different power supplies we have, for example, the DP2000 series and the DP900 series. The next test device we launched this year was the DS70000. It's a digital oscilloscope with two different frequency ranges. First of all, the first frequency range is up to 3 GHz and the second bandwidth is up to 5 GHz. It's a 20 gigasamples per second test device, so we have a very high sample rate. And the memory depth is maximum 2 gigapoints. So you have not only the big sample rate to make a very fine resolution, you have also very big memory to record a lot of data together. We have a very big display with 15.6 inch, which is a touch screen. You can also split this big screen into smaller screens when you have opened different applications. And also, you can automatically adjust the tilt of the screen for more comfortable test possibilities. This oscilloscope has a capability to measure quite fast. We have a waveform capture rate more than 1 million waveforms per second. We have different kind of applications in the scopes. For example, we can measure with a jitter or with real-time eye. We also added some compliance tests for USB 2.0 or for Ethernet 100T base. We're providing, of course, different kind of decodings, and we implemented as a very special tool into this box because we implemented the real-time FFT inside with a maximum calculation speed of 10,000 FFTs per second. Also, this test device can be controlled via web control. The next part, what we launched this year, is new RF probe also for the scopes. We have two versions. One is 3.5 GHz, the other one is 7 GHz. This probe is quite special because we implemented also at the amplifier our own designed ASIC. And we generate a very high linearity over the whole frequency range. Also, trimming is inside, and therefore it's protected against environmental behaviors. The next part, what we want to introduce, is our DG70004. It's a multifunctional arbitrary function generator. This one contains different kind of generators. You can generate, for example, real ARP signals, but you can as well generate complex IQ signals up to a bandwidth of 1.5 GHz. The output frequency is from DC up to 5 GHz. It is a 16-bit resolution, so we have a very fine vertical resolution with this generator. With this generator, you have also the capability to make very, very clean signals. We have, for example, with the carrier, minus 70 dB carrier, spurious-free dynamic range. The sample rate of this generator is 5 gigasamples, but with interpolation, we can increase this to 10 gigasamples for the real signals or to 12 gigasamples for the IQ data. All the marker can be added for each channel, up to 2 markers. We also added a very, very good sequencing into the box with a very big amount of sequences and single sequences. One sequence can also be split in under sequences. We have the same touch screen with the same size like the oscilloscope we presented a few minutes ago. The next part, what we want to introduce, is our new ASIC chipset we used for our HDO series we launched 3 weeks ago. Here you can see Centaurus chipset. It's an analog signal conditioning chip which is implemented at the front end of the oscilloscope. The big skills of this chip is we're reaching a very high dynamic range. Furthermore, we have a very, very low noise floor with this chip. And this is exactly one of the key functionalities why 12-bit oscilloscope has such a high performance, because of the low noise of this front end. The second ASIC chip, it's inside in the scope and it's connected to the analog digital converter. And here This is one of the reasons why we reached the 12-bit. We have a higher resolution. Additionally, the multi-signal timing is quite good. We have up to below 33 femtoseconds. These two ASICs are implemented in our brand new HDO oscilloscopes. It's our new 12-bit oscilloscopes. We have two versions. The HDO 1000 with a separator of 2 gigasamples per second. We have 3 bandwidths with 70, 100 and 200 megahertz. And we have the capabilities to provide our customer 2-channel or 4-channel. We implemented here also an ultra-acquire technology, where we have the chance to increase the waveform capture rate up to 1.5 million waveforms per second. The maximum memory is up to 100 megapoints, so we can also achieve a very big memory. The other one is the HDO 4000. So we have a higher sample rate here. We have up to 4 gigasamples per second. Therefore, we have the chance to increase the bandwidth. We have the bandwidth 200, 400 and 800 megahertz. We have 4-channel solutions in this case, and we reach a low noise value below 18 microvolt RMS. We have also the capabilities to set the vertical settings below to 100 microvolts per diff. So we have the chance to measure very, very small signals with these oscilloscopes with a very high accuracy. Also, the ultra-acquire is inside. And we're providing optionally also a battery pack. That means you can add the battery packs, the standard batteries inside. You don't need a power cord to activate the test device. The device works with the batteries. And you can use standard batteries and change them, of course. The last point of this presentation is our new product, the DSG 5000. The key features of the DSG 5000 are the frequency range. We have frequency ranges from 9 kHz up to 12 gigahertz, or from 9 kHz up to 20 gigahertz. And it's a multi-channel microwave signal generator. So that means we're providing 2, 4, 6 or 8-channel solution. Or you can add them as a modular functionality and increase the number of channels. Here you can see some more key features. For example, you can use the touch screen at the front side to control the test device. Or you can use web control. Alternatively, you can also connect a monitor via HDMI and use your mouse and your keyboard to control the test device in a very easy level. Of course, this test device can also be controlled via Skippy commands in case you prefer to write your own program. The next part is when you're using different channels together, we have a very high fast stability over a very long time. This is specific necessary if you make long-time verifications where you need a very stable phase between these channels. And as you can see, we made a measurement here with 72 hours, and the phase stability is less than 1 degree at a frequency of 10 gigahertz. One of the next core parameter is the fast noise. And here you can see the graphs of the fast noise. And one example is at 1 gigahertz, where we have a fast noise of minus 133 dB carrier normalized to 1 hertz at an offset of 10 kilohertz. You can see also in the other graphs the other frequency ranges in the fast noise, which is as well very good. The next part is the amplitude accuracy, where we have over the whole frequency below 0.5 dB. And this is realized because of our full digital amplitude control technology, where Rigol has a patent on it. Furthermore, we have implemented a high precision amplitude calibration algorithm, which helps to stabilize the amplitude. Here you can see two measurements, one with plus 10 dBm, the other one with minus 30 dBm over the whole frequency range. We implemented also a lot of technologies and capabilities. For example, with that generator, you have the chance to make a frequency sweep, an amplitude sweep, or both together, frequency in combination with amplitude. We're providing as well analog modulation forms like amplitude modulation, frequency modulation, phase modulation, or pulse modulation. You have also the chance to make pulse trains optionally with that generators. Each channel can be controlled independently, or you can control all channels together. This test device can be used maybe together with the DG 70000 for quantum computing, for the stimulation of the quantums. Another part could be used for multiple input, multiple output applications, where you have different antennas and where you can transmit the signals and you have the very high stability between these channels. Another application is radar, where you can use, for example, the pulse train to generate exactly the radar pulses of your need. Another application is, of course, other multi-antenna applications of your need, or in case of EMZ, susceptibility tests, where you can use also a single carrier, for example, with amplitude modulation according to your need, or if you want to stress different frequency ranges, then you can also activate more channels with different frequency ranges to stress a test device on separate cases. Now we can start with our live demonstrations.